Hello! Ho 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 ho! Merry Christmas! All right, this is Jose Luis at Parametric Camp, and welcome to another video in this mini series where we've been working towards illuminating computationally a Christmas tree. So, in this video, I would like to actually show you what all those sequences that we have made in the previous videos, what they look like actually run in a real physical tree. So, first of all, welcome to my apartment. This is my living room. And this is the Christmas tree that we have put together for this exercise. So it's a pretty average Christmas tree. It has a bunch of decoration. I would like to thank my partner for that work. I think she did a really beautiful job. And what we've done is we have wrapped a strip of 500 LEDs on top of the tree. So they roughly start somewhere here, and the last ones are the ones on top. And each one of those LEDs can be controlled individually. Each one of the colors of the LEDs can be controlled with a Raspberry Pi that I have right here on this desk. I have a small monitor and a small keyboard in case I want to sit down and play around with the Raspberry Pi here. But what I will do actually is that for this video, I'm going to control everything from my recording studio, and I'm going to just remote into the Raspberry Pi to do all the control and all the loading of the sequences. Okay. The setup of all this system, I would like to thank Matt Parker from Stand Up Maths for his inspiration. He put this together last year, and he also wrote a calibration routine that using computer vision, you could use. He wrote something so that you could turn each one of the LEDs one at a time, take a picture, rotate the tree a few times, and do some interpolation to figure out where the X, Y, Z of each one of the LEDs was in three-dimensional space. I would like to also thank my students at the university, because they were the ones who actually helped me pull together the physical tree with the LED lights and to write the code to do the calibration in 3D inspired by some of the code that Matt Parker actually put together also. So big thanks to all of them as well. And without further ado, I think what I'm going to do is I'm going to go to my recording studio, and then I'm going to from there remote and load all those sequences and try them on the tree. See you in a second. Whoop. All right, and I just teleported here to my recording studio, but I can still see the tree in my monitor, and everything is happening. Everything that you're seeing is being recorded live from my living room. All right, so what I'm going to do is I'm going to share this thing over here. This is a terminal that I have open right now on my computer, the one that I'm using for live streaming and for recording all of this stuff, okay? So because running this and recording this from the Raspberry Pi is not very easy, especially with OBS, I would rather do the same thing as I would do in the Raspberry Pi, but I'm going to do it remotely. So what I'm going to do is that I'm going to remote from my computer into the Raspberry Pi by SSHing into it. So I'm going to type SSH, the username, which is Pi, then the IP of the Raspberry Pi in my local network. And then it's asking me for a password, so I'm going to enter the password that I have. And right now you can see that I just logged in remotely into my Raspberry Pi. So anything that I enter in my terminal right now is as if I was doing it on the actual Raspberry Pi. SSHing is a really, it's the most popular way of remoting into servers, remoting into different computers from in a low-level way, if you will, okay, without virtual desktops and all that stuff. So now that I'm here, I can see that my Raspberry Pi has a root, so I can enter the desktop, which is what I've placed most of my files because I'm pretty lazy. And you can see that on the desktop, there's a bunch of files that I've been working and prototyping with. So I'm actually going to enter sequences at Parametric Camp. I'm going to clear the screen, and I'm going to list all the files. And you can see that these are all the sequences that we saved as comma separated values as CSV files with our Grasshopper scripts. I have loaded them with a thumb drive on the Raspberry Pi, although I could also upload them remotely here from my desktop. Okay. If you want to see another version, this is all the files that I have. Now, before we actually load them, I want to show you a few cool things we haven't talked about this we haven't talked about this in the stream, but I actually have a bunch of utility files that allow me to play and tweak things on the tree. So for example, there is this turn on script that I can run to turn on individual lights by number. So for example, I can type sudo python 3 and then turn on, and then I can type, for example, I want to turn off the first one, 99, 199, 299, 399, and 499. So the six lights at equal sequences. And then what the script will do is that it will turn them one at a time. So if I run this, you see 1, 2, 3, 4, 5, and 6. The one on the top is the very last one. All right. So now those are on, but I can also, I have this flush routine that I can also use to type to basically turn everything off. So I'm going to sudo python blah blah blah, and I'm just going to flush this. All right, and flushing just turns everything off. All right. Okay, cool. So I'm going to now say, well, now I have a bunch of routines, and the way I'm going to load the routines that come with the CSV files is that I'm going to sudo python 3, I'm going to use the run script, and then I'm going to load one of the ones that I have here as CSV files. All right. Now, which one am I going to use? Well, we're going to go by the chronological order that we did in the videos that we recorded. So I believe the first one is random blinking, correct? But before we do that, let me actually refresh your mind. So we first designed a batch of files that that were not aware of the location of the LEDs in three-dimensional space. So the first one was this one, where we basically randomly just turn them on and off in this crazy way. So basically every frame are set, a random amount of them are turned on and a random amount of them is turned off. So if we run that on the tree, so that is going to produce something like that. I don't know if you can see it, but they're all like blinking really heavily, you know, which is kind of cool, but if you ask me, if you see it in the real world, it's not very pleasant, actually. So I'm going to stop this, okay? And then the next one that we did in the simulation was the same idea, but it was with colors, all right? So what this looks like in the Raspberry Pi is sudo python 3 run, and then it was random blinking and color, I believe. If we do this, it gets loaded, and it's kind of difficult to see from the webcam, but you can see that now there's color, and it's also like the random blinking, which again, this one is particularly not pleasing to the eye. It's definitely not what you want for a nice, soothing Christmas tree. No. All right, so we're gonna cancel that. So what was the next thing we did on the videos? If you remember, we created this animation that was a very simple like pulsing, where all the lights turn on and off at the same time. So how does that look here? So we're gonna say pulse, and I forget what we got. So I think it was pulse uniform. That was the one that we wanted. Okay, so I'm going to load that into the tree. And you can see that they turn all on, and then it turns off, and then they turn on, and they turn off, then turn on. I think the speed that I saved this CSV file was a little too high, so I would probably like this to pulse a little slower. I think so. But anyway, what else did we have? We had another one. This is probably one of my favorites. This is the same idea. All the lights were pulsing, but instead of all pulsing at the same time, they had a random offset between them. So each one of them started and ended at a different pace. So what that looks like on the tree is we have pulse, and then we have pulse with random, was that, I believe? Okay, let us say, yes, exactly. This one is actually really nice. This one is probably one of my favorites from this set, all right? And this one is still like a little too fast, but if you slow it down to like a 5-second animation or so, it's actually quite soothing and quite nice to see in reality. All right, beautiful. I'm just gonna leave this running while we discuss the next one. The next one that we did was, what was it? It was, the same concept, but instead of white lights, we split all the lights randomly in between red lights and green lights to make it a little bit more Christmas themed. So I think what that looks like is that I'm going to say it was Paul's, and then it was Paul's random color, I believe. I think that was the one. Exactly. Can you see how the animation is the exact same one, but now half the ones are red and half the ones are green. I have to say, in the webcam, the colors look much better. In the real world, they're very bright red and they're very bright green, and it's a little too much for my taste. I like things that are a little more, quiet, cool. I'm not sure what the adjective there would be. And then the last one that we designed here was one where we basically create a random pulse, but instead of having, and then the lights had a different offset on when they started and when they ended to pulse. But now in this case, instead of having each one of them start and end randomly at any particular, what we did was, if we had 500 LEDs, each one of them started the pulsing cycle at a slightly increased angle than the previous one, creating this cumulative effect, more like imagine like a sine wave flying through all the LEDs across the strip. So what that looks like on the tree is something like this. So random, I think it was called offset. All right. And then you can see, yeah. How cool is this? Come on. The result of this is that it looks like there's a cone of light that is going from the top to the bottom, but that's basically the result of me arranging the LED lights in a kind of spiral around the tree. So that's kind of why this looks like that. Beautiful, beautiful. But what about spatially aware? What? Wait, hold on. So if you remember, we also work with another set of files where we, for example, we created animations that were spatially aware. And in this case, for coding those animations, we actually took into consideration the X, Y, and Z locations of these LED lights, very much in the way Matt Parker was doing in his original video. So for this, we actually depended on the calibration that we did of the LED lights on top of the tree. We worked really hard on this. My students really put a lot of effort. Yet I don't think we got a result that was as nice as Matt's. So our calibration had a lot of outliers and that were not, for some reason, on the tree, and a lot of. So what I want to say with this is that the results that we're going to see on the tree are actually not going to be as nice as the ones that we see in the simulation, because the sequences have been designed for the coordinates that we have on the simulation. But it turns out that the ones on the actual tree differ. In some areas, they differ quite significantly. That's also the result that all the work, we did it somewhere else, and then I had to bring in the tree in a car, so all the lights moved around. So it's a little bit of a disaster, I have to admit, but conceptually it was there. The first sequence that we designed, sequence that was spatially aware of the location of the LEDs, was one where we had, very simply, we had a plane that we moved vertically from the lower part of the tree to the top part, and where all the LED lights that were near that tree started turning on and off in a gradient manner. All right. So what that looks like on the real tree is actually going to give us, let me flush this. So sudo python 3 flush. All right. I'm going to turn it off, and then I'm going to now refresh my mind. We had moving. All right, so I think the first one that we're talking about, so this would be, let's run, and that would be moving, and then it was a Z plane. All right, All right, so this is the same sequence that I just showed in the simulation. And what you can see now is that we can see that there is this notion of a plane that is moving across the tree. I think it's way more noticeable than in the previous one. So you can see that that's actually quite nice, actually. But perhaps the horizontality or like the perfect section is not so clean. I think there's something like, it looks like the plane is kind of inclined this way on the physical tree. But again, this is due to the difference between the theoretical calibration that we did of the LED light, their position in XYZ, and the actual ones on the physical tree. All right. Now, what else do we have? If you remember on the live stream, we did a similar one where we also worked with the location in the vertical location of the LEDs, but in this case, what we did was that we used the HSV color space. We worked with the hue of the colors, and we moved the hue in Z, creating this effect of a rainbow of color kind of moving along the vertical axis of the tree. So what that looks like on the tree is something like this. So it moves C, and I think it was, what do we have here? It was rainbow, all right? So that's going to look like, yoo-hoo! Oh, that's too bad. The colors don't look great on the webcam, but they actually look really, really good on the real thing. Again, maybe full rainbow, it's a little too much for my taste. I'm more of a minimalist, I think, but this one was actually pretty nice on the Christmas tree. Perhaps it's a little too fast also. I like animations that are a little quieter. We also did one in the video that was the same idea, working with a rainbow that was moving around the tree. But in this case, we created one where the rainbow was rotating around the vertical axis. So we can see the effect of that. If we look at this thing in plan, you can see how there's like a rainbow that is rotating. If we see it vertically, it's a bit more difficult to see. So let's see how that looks like on the actual tree. So I think that for moving, we had rotating rainbow. Okay, so let's run that. This one is, yeah, the calibration for this one is a bit more worrisome, but you can see that there is something, you can see there's slight effect of rotation going on. I can see something there, kind of, all right? Beautiful. And the last one was this one that was basically inspired by the effect of a spotlight that was rotating around a trajectory that we actually drew. So we actually drew a curve that twisted around the Christmas tree, you can see, right? And then we played with the idea of a virtual spotlight, like a sphere of light that was moving around in that trajectory, and then was illuminating the LED lights that were in the area of the one within the radius of that sphere. Okay, so what that looks like, actually I haven't tried this. It's going to be the first time I'm going to try this one live, so I have no idea what this looks like. And then this is going to be spotlight. All right, and all right, whoa, that's cool. Look at that thing. That is so cool. I kind of want to see. Can I go and check it out in the real world? Hold on, hold on. Give me a sec. I really want to see this in the living room. What? Whoa, this is actually quite cool. What? A lot. It's very nice. Alrighty. Okay. So, alrighty. That was really cool, actually. I'm very happy about that. Okay. Well, this was I don't know, can I call this parametric Christmas trees or something? I don't know what to call this, but I'm just going to say I'm very happy. I'm gonna run this again. It was very cool. I'm just gonna say I'm very happy about the result of this exploration. I would very seriously like to thank again. I would like to thank I would like to thank this guy, Matt Parker, who from Stand Up Maths, who was the first one to come up with this idea, who did a video last year where he explained the whole concept of how to wire this stuff, how to do the computer vision algorithm to track them in 3D, and inspired making this and trying to create these animations with the tools that we like in this channel, C#, Grasshopper, geometry, and all that stuff. Thanks a lot, Matt, for contributing this to the community. And I also want to thank my students at the university, Indrajit, Amelia, and Jessica, for helping put together the physical tree, the wiring, the calibration, and all of that stuff. If it wasn't for you, I would have probably not been able to do this today. All right, so that was great. Now, with that, I think this concludes the mini-series of illumination of Christmas trees parametrically. Thank you very much. This was our 2021 seasonal parametric camp work, whatever that is. Maybe we pick up this again next year. Maybe we don't. I don't know. Maybe we do like a joint thing with Matt. Who knows? All the possibilities are endless. Okay. But in any case, thank you for watching this. It was super fun to put this together. It was super fun to explore it. And it was super fun to share this with everyone, as usual. Thank you so much. And if you like this work, maybe consider subscribing to the channel, liking this video, saying hi, or taking everything that you have learned in these videos, coming up with your own animations and submitting them to us on Discord so that maybe we can run them on the tree this year, next year, or whenever we do this. I'm actually planning on holding a Parametric Camp community meeting in a couple of weeks after the recording of this video, and whoever has sequences in a CSV format, I will be more than happy to run them on the tree, just like I'm doing right now. All right? Until then, thank you very much, and see you on some other videos. Bye-bye.